According to the 1999 National Electrical Code, specifically Section 336.4, Type NM cable, often referred to as Romex, is permitted for both exposed and concealed work, but only in normally dry locations. The key consideration is whether the environment in question meets the definition of a normally dry location. The description of the below-grade crawl spaces indicates that they are humid, damp, and sometimes wet due to the infiltration of rainwater. This condition does not align with the NEC intent for a normally dry location. The presence of grade-level open ventilation, vent fans, access hatches, and louvers to the outdoors suggests that these crawl spaces are subject to significant environmental influence, including moisture. The NEC does not provide a specific definition of normally dry locations within Section 336.4. However, the term is generally understood within the electrical industry to mean locations where moisture is not normally present to a degree that it could affect the wiring. Factors that contribute to a location not being considered normally dry include persistent humidity, condensation, water leakage, and direct exposure to the elements. In situations where the environment is consistently damp or wet, the use of Type NM cable is prohibited due to the risk of electrical hazards and premature deterioration of the cable. Damp or wet conditions can lead to the breakdown of the cable's insulation, increasing the risk of short circuits, ground faults, and electrical shock. Furthermore, moisture can corrode the conductors within the cable, reducing their conductivity and potentially leading to overheating. Given that the crawl spaces in question are subject to humidity, dampness, and occasional water infiltration, they cannot be considered normally dry locations as defined by the NEC. Therefore, the installation of Type NM cable in these crawl spaces would not be in compliance with the requirements of the 1999 NEC. Alternative wiring methods that are suitable for damp or wet locations should be used instead. Several types of cable and wiring methods are approved for use in damp or wet locations, each offering varying degrees of protection against moisture. Some common alternatives include firstly Type UF cable, which is an underground feeder cable designed for direct burial in the earth and is also suitable for use in wet locations. Type UF cable has a solid plastic jacket that provides excellent protection against moisture and physical damage. Secondly, Type SE or use cable, specifically when marked as use, can be used in wet locations. SE cable is typically used for above-ground service entrance applications, while use cable is designed for underground service entrance applications. Thirdly, PVC conduit with appropriately rated conductors. PVC conduit is a non-metallic conduit that is resistant to moisture and corrosion. When used with conductors that are rated for wet locations, it provides a reliable wiring method for damp or wet environments. Fourthly, rigid metal conduit RMC or intermediate metal conduit IMC with appropriately rated conductors. RMC and IMC are steel conduits that provide excellent physical protection and can be used in wet locations when properly installed with watertight fittings. Fifthly, liquid-tight flexible metal conduit LFMC or liquid-tight flexible non-metallic conduit LFNC with appropriately rated conductors. LFMC and LFNC are flexible conduits that provide a liquid-tight seal, making them suitable for use in damp or wet locations. When selecting a wiring method for damp or wet locations, it is essential to consider the specific environmental conditions and the requirements of the NEC. Factors to consider include the level of moisture exposure, the potential for physical damage, and the need for corrosion resistance. It is also important to ensure that all fittings and connectors used with the wiring method are rated for wet locations to maintain the integrity of the installation. In addition to selecting an appropriate wiring method, it is crucial to take steps to mitigate moisture in the crawl spaces. This can include improving ventilation, sealing cracks and openings in the foundation, and installing a vapor barrier on the ground. By reducing moisture levels, the risk of electrical hazards and premature deterioration of wiring can be minimized. When working with electrical installations in damp or wet locations, it is essential to follow all applicable safety precautions. This includes disconnecting power before working on any electrical equipment, using appropriate personal protective equipment, and testing the installation after completion to ensure that it is safe and functioning properly. Consulting with a qualified electrician is highly recommended when dealing with electrical installations in challenging environments such as damp or wet crawl spaces. A qualified electrician can assess the specific conditions, select appropriate wiring methods, and ensure that the installation complies with all applicable codes and standards. In summary, the installation of Type NM cable in the described below-grade crawl spaces would not be in compliance with the 1999 NEC due to the presence of humidity, dampness, and occasional water infiltration. Alternative wiring methods suitable for damp or wet locations should be used instead, and steps should be taken to mitigate moisture in the crawl spaces to ensure safe and reliable electrical installation. Remember to always consult the latest edition of the NEC and local codes for the most up-to-date requirements. Additionally, always hire a licensed electrician for electrical work to ensure safety and compliance. Considering the specific NEC Section 336.4 and the potential misinterpretation regarding normally dry locations, let's further clarify the implications and explore related concepts. The primary concern with using Type NM cable in damp or wet locations is the degradation of its non-metallic sheathing and the potential for water to reach the conductors. NM cable is designed for use in environments where it will remain dry, and its materials are not intended to withstand prolonged exposure to moisture. The paper or fiber fillers within NM cable can absorb moisture, which can then lead to corrosion of the conductors and a breakdown of the insulation. This degradation can result in electrical shorts, ground faults, and even fire hazards. Moreover, the presence of moisture can create a path for electrical current to flow through unintended routes, increasing the risk of electric shock. The NEC provides guidelines for selecting appropriate wiring methods based on the environmental conditions of the installation location. These guidelines are intended to ensure that electrical systems are installed safely and reliably. In the case of damp or wet locations, the NEC requires the use of wiring methods that are specifically designed to withstand moisture exposure. As previously mentioned, some common alternatives to Type NM cable for damp or wet locations include Type UF cable, PVC conduit with appropriately rated conductors, and RMC or INC with appropriately rated conductors. Type UF cable is particularly well suited for direct burial applications and for use in areas where it may be exposed to moisture. Its solid plastic jacket provides excellent protection against water infiltration and physical damage. PVC conduit offers a cost-effective and versatile solution for wiring in damp or wet locations. It is resistant to corrosion and can be easily installed. When used with conductors that are rated for wet locations such as Type THWN or XHHW, it provides a reliable wiring method for these environments. RMC and IMC are suitable for applications where physical protection is a primary concern. They are made of steel and offer excellent resistance to impact and crushing. When properly installed with watertight fittings, they can provide a durable and reliable wiring method for damp or wet locations. In addition to selecting an appropriate wiring method, it is also important to consider the grounding requirements for electrical systems in damp or wet locations. The NEC requires that all electrical equipment in these locations be properly grounded to minimize the risk of electric shock. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. This helps to protect people from electric shock and prevents damage to electrical equipment. When installing grounding conductors in damp or wet locations, it is important to use corrosion-resistant materials and to ensure that all connections are properly made. The NEC also requires the use of ground fault circuit interrupters, or GFCIs, in certain locations where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor areas. GFCIs are designed to detect even small amounts of current leakage to ground and to quickly de-energize the circuit, preventing electric shock. In the context of the crawl spaces described, it is highly recommended to install GFCIs on all circuits that serve outlets or equipment in these areas. This will provide an additional layer of protection against electric shock in the event of a fault. Furthermore, regular inspections of the electrical system in the crawl spaces are essential to identify and address any potential problems before they become serious hazards. Inspections should include checking for signs of moisture damage, corrosion, and loose connections. Any damaged or deteriorated wiring or equipment should be repaired or replaced immediately. When performing electrical work in damp or wet locations, it is crucial to follow all applicable safety precautions. This includes wearing appropriate personal protective equipment such as rubber gloves and safety glasses, and using insulated tools. It is also important to disconnect power to the circuit being worked on before starting any work. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. A qualified electrician has the knowledge, skills, and experience to safely and properly install and maintain electrical systems in damp or wet locations. They can also ensure that the installation complies with all applicable codes and standards. In summary, the installation of Type NM cable in damp or wet crawl spaces is not permitted by the NEC. Alternative wiring methods that are specifically designed for these environments should be used instead. It is also important to take steps to mitigate moisture in the crawl spaces and to follow all applicable safety precautions when working with electricity in these locations. Regular inspections of the electrical system are essential to identify and address any potential problems before they become serious hazards. And remember, when in doubt, consult with a qualified electrician. Now, let's consider the specific implications of using the 1999 NEC, as this is the code version recognized by the local authorities mentioned in the question. While electrical codes are updated periodically to reflect new technologies, safety standards, and best practices, the fundamental principles regarding wiring methods in damp or wet locations remain consistent across different editions of the NEC. The 1999 NEC, like subsequent editions, emphasizes the importance of selecting wiring methods that are appropriate for the environmental conditions of the installation. Section 336.4 of the 1999 NEC, which specifically addresses the use of Type NM cable, clearly states that it is permitted only in normally dry locations. This requirement is intended to prevent the degradation of the cable's insulation and conductors due to moisture exposure. Even though the 1999 NEC is the recognized code version in this case, it is still essential to consult the latest edition of the NEC and any applicable local codes or regulations for the most up-to-date requirements. Local codes may have additional restrictions or requirements that are not included in NEC. Furthermore, it is always a good practice to follow the most stringent requirements, even if they are not explicitly mandated by the local authorities. This will help to ensure that the electrical installation is as safe and reliable as possible. In addition to the NEC, other standards and guidelines may also be relevant to electrical installations in damp or wet locations. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for electrical enclosures and equipment that are used in these environments. NEMA enclosure types are classified based on their ability to protect against various environmental conditions such as water, dust, and corrosion. When selecting electrical enclosures for use in damp or wet locations, it is important to choose enclosures that are specifically designed for these environments. NEMA 4 and 4X enclosures, for example, are designed to provide protection against splashing water, hose-directed water, and corrosion. These enclosures are commonly used in outdoor applications and in areas where equipment may be exposed to moisture. In addition to enclosures, other electrical equipment that is used in damp or wet locations should also be rated for these environments. This includes switches, receptacles, lighting fixtures, and other devices. Look for equipment that is marked as weatherproof or wet location to ensure that it is suitable for use in these areas. When installing electrical equipment in damp or wet locations, it is important to follow the manufacturer's instructions carefully. This will help to ensure that the equipment is installed correctly and that it will function properly. It is also important to use appropriate fittings and connectors to maintain the integrity of the installation. In summary, even though the 1999 NEC is the recognized code version, it is still essential to consult the latest edition of the NEC and any applicable local codes or regulations for the most up-to-date requirements. It is also important to follow the most stringent requirements, even if they are not explicitly mandated by the local authorities. Furthermore, Other standards and guidelines, such as NEM enclosure types, may also be relevant to electrical installations in damp or wet locations. By following these guidelines, you can help to ensure that the electrical installation is as safe and reliable as possible. Let's expand further into the practical aspects of selecting and installing alternative wiring methods in damp crawl spaces, going beyond the general recommendations. For Type UF cable, when burying it underground to supply power to an outbuilding connected to the crawl space, adhere to NEC Table 300.5 for minimum burial depths. The depth depends on voltage and location, but generally, for residential applications, 12 inches is typical for circuits rated 120 volts or 240 volts. Always check the specific table for any exceptions or specific requirements based on local amendments. When using PVC conduit, consider Schedule 80 PVC for added physical protection, especially if the crawl space is prone to flooding or physical disturbances. Use proper PVC glue and fittings listed for wet locations to maintain a watertight seal. Ensure the conduit is adequately supported according to NEC Section 352.30 to prevent sagging and potential damage. If opting for RMC or IMC, remember that these metallic conduits require proper grounding to ensure safety. Use grounding bushings and jumpers to create a continuous ground path back to the service panel. Also, apply a corrosion-resistant coating to the conduit, especially at joints and couplings, to prevent rust and degradation in the damp environment. With LFMC or LFNC, choose fittings that are specifically designed for these conduit types and listed for wet locations. Ensure that the conduit is properly supported to prevent it from kinking or becoming damaged. Be mindful of the temperature rating of the conductors used inside the conduit, as some flexible conduits can accumulate heat. For conductor selection, in damp or wet locations, always use conductors with a W designation in their insulation type, such as THWN2 or XHHW2. These conductors are specifically designed to withstand moisture and are suitable for use in wet environments. When splicing conductors in the crawl space, use waterproof connectors or splicing kits listed for direct burial or wet locations. These connectors typically use a sealant or potting compound to prevent moisture from entering the connection. Ensure that the connectors are properly installed according to the manufacturer's instructions to maintain a watertight seal. Consider using junction boxes listed for wet locations, such as NEMA 4 or 4X rated boxes. These boxes are designed to prevent water from entering and damaging the electrical connections inside. Mount the junction boxes on a solid surface, such as a concrete wall or a treated wood post, to prevent them from coming into contact with the ground. When installing receptacles or other electrical devices in the crawl space, use weatherproof covers to protect them from moisture. These covers typically have a gasket that seals against the device when it is not in use. Make sure the covers are properly installed and maintained to ensure that they provide adequate protection. Improving ventilation is critical. Install a dehumidifier designed for crawl space use. This will help to remove moisture from the air and prevent condensation. Ensure that the dehumidifier is properly sized for the crawl space and that it is regularly maintained. Seal all cracks and openings in the foundation walls and floors to prevent moisture from entering the crawl space. Use a waterproof sealant to fill any cracks or gaps. Consider installing a vapor barrier on the ground of the crawl space. This will help to prevent moisture from evaporating from the ground and entering the air. Overlap the edges of the vapor barrier and seal them with tape to create a continuous barrier. Installing a sump pump is another option, especially if the crawl space is prone to flooding. The sump pump will automatically pump out any water that accumulates in a crawl space. Ensure that the sump pump is properly sized for the crawl space and that it has a backup power source in case of a power outage. In addition to the above measures, it is also important to regularly inspect the crawl space with signs of moisture damage. Check for mold growth, wood rot, and water stains. If any of these signs are present, take steps to address the underlying cause of the moisture problem. Also, ensure that gutters and downspouts are properly maintained to divert water away from the foundation. Clean the gutters regularly and make sure that the downspouts extend far enough away from the foundation to prevent water from pooling near the crawl space. It's highly advisable to consult with a qualified electrician and a foundation specialist to assess the specific conditions of the crawl space and to develop a comprehensive plan for addressing moisture problems and ensuring a safe and reliable electrical installation. Remember, safety is paramount when working with electricity, especially in damp or wet environments. Always follow all applicable codes and regulations, and if you are not comfortable performing the work yourself, hire a qualified professional.